Oh, welcome. This is now question number 2 for Edexcel's C4 June 2015 past paper. Okay, so we're given this equation of a curve, okay, that is x squared take 3xy take 4y squared plus 64. And we're asked to find dy dx in terms of x and y. In other words, obviously we're asked to differentiate this curve and give the differential equation. Now the first thing I spot here, well obviously it's going to be implicit differentiation because we've got y's and x's involved, but more than that, what I've spotted here is that we've got one term times another in terms of we've got 3x times y. So when we go through this differentiation, okay, we're going to have to differentiate that part of the curve on its own. Okay, so we're going to take it out to the side over here, and because it's one product times another product, we have to use the products rule. Now, you could go, well, how are we going to split it up? Because it's 3 times x times y. So is it 3x times y, or is it 3y times x? Well, you always assume it's just 3 times x times y, okay? So therefore, what I'm trying to say is we let u equal 3x. Okay, so therefore, u dashed, or du dx, is 3. V, well that's just equal to y. But then when we do v dash, because we're differentiating y, obviously when we normally differentiate something we do dx, so we can't differentiate y with respect to x, so we do it with respect to dy dx. In other words, we just put 1 dy dx, sorry, because the differential of y is 1. Okay, just put dy dx, and that is to do with the chain rule. And as I said in my last video, when that happened, okay, I do a related rate of change C4 playlist in there, and it kind of explains why this is the case, okay? But essentially what this is now is a product rule, so it's uv dash plus vu dash, whichever way around you want to do it, okay? So I'm going to do vu dash plus uv dash, okay? So it's y times 3 plus 3x times 1 times dy dx. Okay, so obviously when you expand that out, that's 3y plus 3x dy dx. Now, the thing that always gets me is you've got to remember that 3x is times dy dx. It's not the 3y that's times dy dx. Now, that looks obvious, but the reason it messes with my mind is because, well, when we differentiate a term of y, well, we differentiate it with respect to y. But when we differentiate a term of x, such as 3x, we don't put dy dx next to it. But you've got to remember that 3x is times 1 dy dx, because we've differentiated y to get 1 dy dx, and we times it by 3, we get 3x dy dx, okay? So that's the thing. Now, the next bit is quite a common mistake to make. Now, in this question, and some other ones, it doesn't matter. But let's just go through and I'll explain, okay? So the first term is differentiate that, well, that's squared, but simply just 2x. And then we take, well, we don't just take 3xy, we take the differential of 3xy. But because the differential of 3xy is 3y plus 3x dy dx, you have to take away all of that. So in other words, we put this in brackets, so it's 3y plus 3x dy dx. And I'll expand it out in a minute. Okay, well, differential of 4y squared, well, so that's just 8y dy dx, simple differential. And obviously the differential of 64, that's just 0, okay? So that all equals 0. Now you may be going, why the hell did we put brackets there? It's obviously just 2x, take 3y, take 3x dy dx, take 8y dy dx. Now the reason I did that, I see that equals 0. The reason I did that is because some differentials say it might have differentiated to get 3y, take 3x dy dx. And obviously, if you had a minus there, that would obviously mean you take away a negative 3x dy dx. Now that's not the case for this, I'm just probably confusing you. But it could possibly be, because you are taking away the differential of 3xy. And if the differential of 3xy was, say, 3y, take 3x dy dx instead of plus 3x dy dx, obviously you would have to sub a minus in there. So when you take away 3y, and then you take away negative 3x dy dx, you end up adding 3x dy dx. So it's kind of crucial to put these double brackets there. Now I do emphasise it because it's quite a common mistake. And I've, so not the genius I am, I made it once or twice, so it's very easily made, obviously. Okay, then because what we do here is move all the dy dx's onto one side and leave all of the non-dy dx's, or just linear, well not linear, that's the wrong word, just take all the dy dx's to one side and leave the others where they are. Now, because what ideally would be easiest is to have the dy dx positive, and that's very easily to do because, well, these numbers here, 2x take 3y, if we move them over to the other side, so in other words, if we took away 2x and added 3y, well, we'd be left with negative 3x, take a y, all times dy dx, because obviously we're going to take out dy dx as a common factor, okay, and it'll be equal to 3y minus 2x. Now, that'll look a bit complicated, because it's likely to get some minus errors in there, so what we always do is try and keep the dy dx positive if possible. So in this case, what we do is we move the dy dx onto the right hand side, so we're left with 2x take 3y is equal to 3x plus 8y, and because we're taking out dy dx as a common factor, we times it all by dy dx. Okay, so therefore, it's what it says now is 2x take 3y is equal to 3x plus 8y times dy dx. So in case just of making dy dx a subject now, so dy dx is equal to 2x take 3y over 3x plus 8y. It's not asked to do anything else for part A, so it's simply just coming up with that differential equation, which ends up being 2x take 3y over 3y plus, over 3x plus 8y. So and it says it's not asked to do anything else for 3A, so it's simply just as easy as that. So let me just make sure I've got it right here. You know, I'm a genius I am, I'm fairly sure which one to double check. This mark scheme's a faff doing it. Sorry, a sec. Let's take 3y over 3x plus, yeah. By the way, if you'd have done it the other way, okay, so if you'd have moved the 2x and 3y over to the other side, you would have got dy dx to be 3y take 2x over minus 3x minus 8y. And you can see that's a lot more of a mess than that. So I just learned that method of keeping the dy dx is positive. So in this case, we move both the dy dx's over to the right hand side. Okay, so I'll just write that up the top because obviously we're going to be moving on to part B next. So dy dx was equal to 2x take 3y over 3x plus 8y. Okay, so that's your answer obviously to part A. So let's just rub this off. Okay, so part B says, now this is a bit of a weird question, sorry, so pop one in, sorry. We all got a boost once in a while. We need to find the coordinates where dy dx equals 0. So logically, the first thing you do, if you didn't know what to do, you'd make dy dx equal to 0. It kind of defeats the object. If you didn't know what to do, you knew what to do. Well, kind of stupid wording, but never mind. You make the differential equal to 0. Okay, so just make that equal to 0. So 2x take 3y over 3x plus 8y equal to 0. Then we times both sides of this equation by 3x plus 8y. In other words, we're left with 2x take 3y is equal to 0. Okay, and then obviously the only thing we can do from here, we see where we can go, is rearrange this to get either x or y to be the subject. Now, x looks easier because we just have to divide both sides by 2, and that's a lot easier than dividing both sides by 3. So, well, it doesn't matter actually, I just chose x, okay? So 2x is equal to 3y, so therefore x is equal to 3y over 2. Okay? Okay, so what we're going to do now, you have to think, well, where can we go? What it wants is the coordinates of the point C, which is this curve, where dy dx equals 0. Now, that's the x coordinate where dy dx equals 0. So if you put x to be 3y over 2 into the differential equation we found in part A, okay, you will get a gradient of 0. In other words, a maximum or minimum point. But we're not really interested in that. Probably just confusing you with some C2 knowledge. Now, what we have to do here is let's think of it. It wants the coordinates of the curve. Now, we've got the coordinate of x in terms of y when dy dx equals 0, but that doesn't help us because we need to know what y is to be able to say, well, this is what x is. And obviously vice versa, if you'd have rearranged that to give y instead of x. Now, it's crucial. It doesn't matter. I've just picked it to rearrange x in terms of y, but you could have done y is equal to 2x over 3. It doesn't matter, but the next principle, obviously, you must follow. Now, there's only a couple of equations that we've got so far. Well, the first one is the equation of the curve, which we were given at the start, and the second is the differential equation, which we've just put equal to 0. So there's no point faffing around with this dy dx anymore, because that's not going to give us any more help than we've already got. So the only other thing we can do, because there's no other information on here, is it's almost like simultaneous equations, in the sense that you sub one into the other. Because we want to know what this is the coordinate of x in terms of y, so it's a coordinate on the curve, it's just we're giving it in terms of y instead of a raw value, okay? So what we need to do is we need to find the value of, I know we've got x in terms of y, and that's not really helpful, but well, we know what, in this curve here, we've got basically, shorthand is, x equal to 3y over 2, and we've got this equation of the curve which will enable us to work out the points of x and y, okay? So we need to sub x into that which is, we got is equal to 3y over 2, because that's the coordinate of x in terms of y, where the gradient is equal to 0. Okay, so we need to know the coordinates, so we sub x to be 3y over 2 into the equation of the curve, okay? Now it is going to look a little bit messy, but there's nothing wrong with that. Okay, so we know x is equal to 3y over 2. Okay, so 3y over 2, we just sub in, so that's 3 over 2 all squared. Take 3 times x, which is 3 times 3y over 2, times y, take 4y squared, plus 64 is equal to 0. Okay. Then it's just a case of expanding this and simplifying it down. Well, 3y, take 3y over 2 all squared, where you just square top, square bottom. So you get 9y squared over 4. And then you do 3 times 3y over 2, which is obviously 9y over 2. But we also need to times that by y. So obviously it's minus 9y squared over 2. Now if you wonder where I got that from, it's this second term here, okay, when it said you do 3 times 3y over 2. Now I didn't write that down because we also needed to times it by y. There's no point writing it down and doing 9y over 2 times y, because you can do that quite easily. So there's no point creating a whole other step, it'd just be a waste of time. Okay, and then it's just minus 4y squared plus 64 equal to 0. Now personally, what we need to do here is, it looks like essentially what we've got here is almost like a quadratic equation, because normally you would see it in terms of x, but because we've subbed x to be in terms of y, we've got it all in terms of y. Basically we've just subbed x to be y and got it all in terms of y. And it might have helped actually if we'd have subbed, when I'm saying sub x in terms of y, what I mean is when we make this differential equal to 0, we times both sides by 3x plus 8y. So we know that when the gradient is equal to 0, 2x take 3y is equal to 0, okay? Because we just times both sides of this differential equation when it's equal to 0 by 3x plus 8y. So therefore, if 2x take 3y is equal to 0, we made it in terms of, we got the, so that says when the gradient is equal to 0, the 2 times the x coordinate is equal to 3 times the y coordinate, okay? So then we just sub, whichever rearrangement we did, okay, so if we arrange it to say x equals something, then we sub x equals 3y over 2 into this equation and then got it all in terms of y. And then what we have, when we simplify all this down, is we get a quadratic equation. So we'll simplify all this down because we've got 3 terms of y squared together. So when we simplify it all down, we get 64 minus 25 y squared over 4 is equal to 0. Okay, so that says when the gradient is 0, 64 take 25y squared over 0 is equal to 0. And the reason it's equal to 0 is not because that's the gradient function. Remember, this is the gradient function over here. And when we worked out what x in terms of y was, we just said times both sides by 3x plus 8y, so 2x take 3y equals 0, so you rearrange it to get x in terms of y. So 2x take 3y is equal to 0, so I said x equals 3y over 2. Okay, and then we subbed it into the equation of this curve, and then simplified it down, we've got this quadratic. Now the reason it's equal to 0 is because this equation of a curve is equal to 0, not because it's the gradient function. Remember, this is the gradient function over here. So that kind of hopefully, I know I've gone over it a few times, but I don't think I made it too clear in my working out there. I've kind of need a drink because again, I've gone far too enjoyed into it. So obviously what we need to do here is work out what y is. Okay, so you can rearrange it and times both sides by 4. So in other words, what happens is you do 25 y squared over 4, obviously that's equal to 64, and then times both sides of the equation by 4, you can just times it all by 4 straight away and rearrange it. So you get 25y squared is equal to 256, because that is the answer to 64 times 4. In other words, 64 times 4. Well, it's the same word actually, but you know. Anyway, divide both sides by 25. So you get y squared is equal to 256 over 25. Okay, and then we square root both sides. So we get y is equal to plus or minus 16 fifths. Now, you go, well, which one do I choose? Do I choose plus 16 fifths or negative 16 fifths? Well, if you look in the question, normally, if there's only one answer, okay, in terms of y, it will say y needs to be greater than, needs to be greater than 0 or less than 1 or whatever it might be. But in this case, it says find the coordinates of point C where dy dx equals 0. So that hints there's going to be there's going to be two sets of coordinates. In other words, there's going to be two y values and two x values. So we take both positive and negative y values. Okay, so in other words, what we do is we say, well, we know y is equal to either positive 16 fifths or negative 16 fifths. But what's the x value which is associated with one of them y values? Okay, so in other words, if y is equal to positive 16 fifths, what's the x value at that point? And similarly, if y is equal to negative 16 fifths, what's the x value at that point? Okay, so what we do is simply just, well, the only equation that gives us, when we've got y value and we want the x value, there's no point subbing it into the gradient function. The only thing we can do is sub it back into the, going back. I am 18 by the way, so I was broken obviously. Obviously you knew I was 18 for some reason, but you get the idea. So you sub it back into the equation of the curve and you simplify down to find your value of y. Now, actually, I don't say why you couldn't sub it into the gradient function. If you want to have a go at subbing y to be positive 16 fifths and negative 16 fifths into this gradient equation and finding x, then please do, because hopefully it should give you the same answer. But I would advise not to do that, because you've got a value for y, to find a corresponding value for x, sub it into the original equation of the curve. Okay, so if you want to, try subbing it into the gradient function. If it gives you the same answer, great, but I think it's just coincidence. And I don't know why I'm saying all this because it's pointless. So if you ignore all that and just sub because we've got the equation, we've got the point y where the gradient is e0, sub it into this equation, the original equation of the curve, okay, and simplify it down. So you sub y to be positive 16 fifths, and then another one where you sub y to be negative 16 fifths, and when you put it into the equation, simplify it down to get x, okay, and you should get values for x. Now, when you sub y to be positive 16 fifths or negative 16 fifths, what you'll end up with is another quadratic equation, but this time in terms of x. Okay, so therefore what you need to do is simply sub in, simply use the quadratic formula to find the values for x. Okay, and what you should get is that when you do it, okay, it doesn't matter if you sub positive 16 fifths or negative 16 fifths into the equation, okay, for the curve, you should get x to be a value of 24 fifths. Okay, so in other words, when y is equal to positive 16 fifths, x is equal to 24 over 5, and when y is negative 16 fifths, x is equal to x is also equal to 24 fifths. Okay, so your coordinates, therefore, you need to put in coordinate form. So x is 24 fifths when y is positive 16 fifths, and the other coordinate is 24 fifths. When x is 24 fifths, y is equal to 16 fifths. Okay, and they're your two coordinates. Now, you could have done it from the perspective that you would have rearranged the equation. Okay, so you would have arranged a differential equation, so you would have got 2x take 3y is equal to 0, and said, well, I'll rearrange that in terms of y, so y is equal to 2x over 3, and done exactly the same thing, the same method in terms of subbing y to be 2x over 3 into the equation of the curve, and simplifying down like we have done, but just a fact, you would have got exactly the same answers. So you don't need to do it again. It'd just be a waste of time. So if you've done it in terms of you rearranged it to get x in terms of y and then subbed into the curve and used all this method that we have done, there's no point doing it again, but this time for the other term. So if you'd have rearranged it to get y, okay, there's no point rearranging the differential curve, the 2x take 3y. There's no point rearranging it in terms of y if you've already rearranged it in terms of x and put it into the equation. Okay, there's no point in doing that. So sorry for waffling on. I just wanted to clarify any possible questions that might arise from this, but that is the end of question 2. I probably talked it out way more than it's worth, but it's worth a nice 11 marks. Okay, so question 2, that's quite a nice one. So thanks for watching. Hopefully it's been helpful, and again, any questions or if I've confused you too much, please do comment below and I'll get back to you obviously as soon as I can. And if you want me to do this video again, please do let me know, and I'll try and alter it in a different way, or put some speech bubbles if it's not making sense for you. Okay, so thanks for watching, and hopefully we'll see you in the next video.